resistor in series. What happens if we connect the resistors in series? What is the value of current? Let us try to understand with an activity. Join three resistors in series connection, connecting them with a battery of 6 volt and ammeter and the plug key with the connecting wire, plug the key and the note on the ammeter reading. Change the position of ammeter in the circuit anywhere and the reading. We can conclude that in series combination of resistor, the ammeter reading is same anywhere in the circuit. Now connect voltmeter in the parallel across the ends of A and F. Take voltmeter reading. Take out of plug key and disconnect the voltmeter. Now connect the voltmeter across the A and B, plug key and take the reading of the voltmeter, say V1 is equal to 3 volt. Similarly, connect the voltmeter across C and D and E and F. Take reading. In each case says V2 is equal to 2 volt and V3 is equal to 1 volt. And V1, V2 and V3 we get 6 volt. You will observe that the total potential difference across a combination of a resistors in series is equal to the sum of the potential difference across the individual resistance. That is, V is equal to V1 plus V2 plus V3. Applying the Ohm's law to the entire circuit, we have V is equal to IR on applying Ohm's law to the three resistors separately. We further have V is equal to V1 plus V2 plus V3. Then V is equal to IR. Therefore, V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. Now applying the Ohm's law, IR is equal to IR1 plus IR2 plus IR3. Or we get RS is equal to R1 plus R2 plus R3. We can conclude that when the resistors are connected in series, the resultant resistance equal to the sum of the individual resistance. Resistors in parallel. Now let us see the parallel arrangement of resistors. Take three resistors, say R1, R2 and R3 and ammeter, voltmeter, battery, plug key. Connect the three resistors R1, R2 and R3 in a parallel to each other in a circuit with a battery, plug key and ammeter. Connect voltmeter in parallel with the combination of resistors. Plug the key and note the ammeter readings I and voltmeter reading V. Take out the plug from the key, remove the ammeter and voltmeter from the circuit. Connect the voltmeter across each other resistors and insert the ammeter in series with the resistor R. Note the ammeter reading I. Similarly, connect the voltmeter and the ammeter with the other two resistors I2 and I3. We can say that the total current in a circuit is equal to the sum of the current I1, I2 and I3 through resistors. By applying the Ohm's law to the parallel combination of resistors, we have I is equal to V divided by Rp. Now, on applying the Ohm's law to each resistor, I is equal to V divided by Rp, I1 is equal to V divided by R1, I2 is equal to V divided by R2 and I3 is equal to V divided by R3. Substituting the 1, 2, 3 and 4 in B, we get V divided by Rp is equal to V divided by R1 plus V divided by R2 plus V divided by R3, or 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. We may conclude that the reciprocal of resistance Rp is equal to the sum of the reciprocal of individual resistance. Thank you for watching. Please subscribe and share.